Okay, our second video is dealing with the next couple lessons that we went over, where we were actually solving equations using the algebra tiles. So I'm going to go ahead and write out our first equation over here, which is going to be 4x minus 3 equals x plus 3. So again, on your assessment, you will have to create an algebra tile mat to show this expression. Then you will have to simplify that mat, and then you will have to answer the or state the actual answer to the problem. Keep in mind there's 3 types of solutions. There is an actual answer where you get x equals 2 or x equals 5 or -1. And then there are no solutions and infinite solutions. So remember, whenever you're solving it on the assessment, if you have 0 equals 0 or 5 equals 5, that means it's infinite solutions. And if you have 2 equals 3, which does not equal, those are not incorrect, then that would be no solution. So again, you can pause this video and go ahead and create your mat and try to solve it, and then press play again. Here we go. So first thing we're going to do is create this mat. So on this left-hand side, we're going to take the left-hand side, which is 4x. So I'm going to take and I'm going to create 4 x's. Okay. And then minus 3. So remember, on the minus side, we're going to put 3. Okay. Then on the right-hand side, we're going to have just one x and then a plus 3. This is a simpler problem to start off with, and then we'll work on a more difficult one next. Okay, that is our equation set up. Our first legal move that we are allowed to do is to add the opposite. So we are going to take everything on the bottom half and we're going to flip it. And remember, when we flip it, we want to change that sign. So instead of being positive still, it's now negative. Same thing over here. Perfect. Again, I can rewrite this. So I can come over here. I still have my 4 x's. Nothing happened with that. But now I have plus that -3. And over here, I still have that 1x. Oh, I'm so sorry. I put this on the positive or on the negative side when it should have been on the positive side. Let me just switch these over really quickly, because it was a +3, so we're adding +3 to this side. And then this stays as +3 because we didn't do anything to that. Our next step, and again, if we were to write out the expression that we did, we added the opposites over here. I'm not going to write it because I don't have a lot of space, but you would be adding the opposites here. Our next thing is removing 0 pairs. Well, if we look at this left side, there are no 0 pairs. If we look at this right side, there are no 0 pairs. So I don't have to worry about that in this problem. My next step, though, is I want to take any like terms that are on both sides away. So remember, if I have an x on this side and I have an x on this side, I can take those 2 away. So I'm going to take those away. And again, that is, imagine I'm subtracting 1x from both sides, which is going to wind up with 3 x's over here. So I have my 3 x's on this side, and then I have my plus that -3. And on this side, I only have 3 left. Perfect. Now remember, our next legal move is we want all of the variables or letters on one side and all of the numbers on the other. So I want to take these 3 numbers and I want to move them to this side. Remember, just like whenever I moved it from down here up here, I have to flip the sign. Whenever I move it from one side to the other, I have to flip the sign. So I'm adding these 3 -1s over to this side. So again, the way I can write that is I'm going to take and I'm going to add these 3 negatives onto the other side. So again, I will end up with 3x on this side because nothing has changed on the left side. And on this side, I'm going to have 6. And then my last and final step is you want to separate it, remember? So we want to take and break them into even groups. So if I take and I put 1 in this group and 1 in this group and 1 in this group, and then I do that again, I have x equals 2. So I divided them into groups. So think about the same thing as over here. I can divide these into 3 groups, and I will have 6 divided by 3, which is 2. And that's my final answer. That is our first problem. Our second problem, I'm going to go ahead and switch to a new screen. Our second problem, let me go ahead and write it up here. It is a little bit longer, so a little bit more complex. We have 3x minus, and then in parentheses we are going to have x plus 2, and then equals 4x minus 1 minus 2x. So this is our new equation. Again, a little bit longer and more complex. So first things first, again, if you want to pause this and try it yourself, first thing we are going to do is we are going to create that on here. So let's see, I have 3 x's. There we go. And then on my minus side, I have another x, because it's a positive x, and I have 2. Okay, so that I've created this side. Now I'm going to create this side on the other side. So I have 4 x's. There we go. And then I have, on my minus side, I have a minus 1. And then I have minus 2 more x's. Alright, so I've now created my board. So first step is I want to add the opposite. So I'm going to take and move these up and switch the signs. I'm going to move these up and switch the signs. Perfect. So that's what I have. So I've done my adding the opposites. Now I'm going to cancel out my 0 pairs and combine like terms. So right here I have a nice 0 pair, so I'm going to take these guys away. I have a 0 pair here, so I'm going to take those away. Oopsie. I have another 0 pair here, so I'm going to take those away. And then I can combine my like terms, right? So over here, I'm going to go ahead and write out what I've done. So over here, I only have 2x minus or plus a negative 2. And on this side, I have a 2x and a plus a negative 1. Okay, and again, I combined like terms and I canceled out my 0 pairs. So now, I'm going to take and I'm going to move or take away anything on both sides that are the same. So I notice on this side I have 2 x's and on this side I have 2 x's. So that means I can take these 2 matching ones away and I can take these 2 matching ones away. Notice I don't have any more x's. Those x's canceled. I subtracted a 2x from this side, and I subtracted a 2x from this side. And when I did that, these 2 both canceled out, and I ended up with this negative 2 equals a negative 1. I can also take this pair away because these 2 are also on the same or on opposite sides, and they're the exact same. So if I take those 2 away, I could even say, okay, well, even more, I have a negative 1 equals a 0. Well, in both of these cases, do either of these actually equal each other? Is a -2 the same thing as a -1? No. Is a -1 the same thing as a 0? No. So that means we have no more x's, which means this is no solution. So our answer for this problem would be no solution. Again, even if I had an x left over, so if I had an x on this side and a -1 on this side, x equals -1, perfect, that's a solution. But as soon as my x is gone and there's nothing left on this side, there's no more x's, no more y's, no more variables, then I have no solution. Had this ended up, sorry, I'm just going to show you a couple things. Had this ended up as -1 equals -1, what type of solution would that have been? Well, I look at it, -1 does equal -1, which means instead of no solution, because it's not a correct answer, since it is correct, that would be our infinite many solutions, or infinite solutions. So again, keep in mind you have 3 types of solutions. You have x equals, and then a number, -1. That's my answer, right? Or you have no solution because you have no x's and the equation left is not equal. Or you have infinite solutions when the 2 answers are left and they are equal.